we're going to look at something interesting. This equation right here, y equals x to the power x. This equation has a plot something like this. Here x direction, here y direction. If this is 1 and this is 2, this is 3, and if this is 1, this is 2, this is 3. It's when x equals 0, y becomes is 1 is the best answer. It becomes like this, and then it goes right straight like this. Why should this function increase right here when it's decreasing towards 1 or 2 or infinity? Why should it increase suddenly here? This point right here, I'm going to write that for you guys. .368 comma, sorry, let me remove this, comma 0.692. But why should this function increase right here? We have a pure mathematical reason for that. That's why I'm going to derive and show it to you guys. First, in order for a function to be increasing function, we have to remember something, that dy divided by dx must have a slope that is greater than 0. This is true because if it is an increasing function. Now what we're going to do for this equation is we're going to take log on both sides. Log y equals x log x, because log x to the power of x, the x on the power will come to the front, so it will become like this. Now differentiating on both sides, differentiating log y divided by dx equals differentiation on both sides, d by dx x dot log x. Now here log y is differentiated. We only need to differentiate y separately, and then we need to differentiate the y function. That's the formula to differentiate log y. So what we're going to get is 1 by y, because log y differentiated becomes 1 by y, and y differentiate y separately. This is dy by dx equals, same here, differentiate x separately, and then leave the log x multiplied, and differentiate log x separately, leave the x multiplied. This is also known rule in differentiation. So d by dx x differentiated towards log x. Log x will just gonna be stay there without, we're only going to differentiate x, because in the next term we will be differentiating only the log x. D by dx log x, and we're going to keep x here without differentiating. This is the way we need to differentiate. Then what we're going to get is 1 by y dy by dx equals, differentiating x gives us 1, and this one will not be differentiated, so we have log x, and we have here log x differentiated will give us 1 by x and dot x, which is multiplication, multiply x. Now this one will cancel out. Now we will get 1 plus log x, while if we rearrange 1 plus log x, and y should be carried to the opposite side, so dy by dx equals y times 1 plus log x. Now y, we already know what is y, x to the power x times 1 plus log x. Now we know here, from here, dy by dx should be greater than 0, so this one should be greater than 0. Now x to the power x should be greater than 0. At the same time, 1 plus log x should also be greater than 0. So either if this should be greater than 0 or this should be greater than 0. So what we're going to do is, we're going to do 1 plus log x, set this greater than 0. Now log e x greater than log e 1 by e. Because we have 1 here, taken to the other side, this is what we get. Now what do we have? X is greater than 1 by e. Excuse me, just a minute. One by e. Now we know the value of e is e equals 2.7 and something, so x will give us 1 by 2.7 something. We have to put almost equal to, because otherwise it will be manipulate infinity. We don't want to do manipulating infinity, so this one will equal to 0.368, somewhere around that, so almost. So this is the reason why it starts to increase right at this number here. That's where it will start to increase. So this is the reason. This is pure mathematical reason. We do not have a physical, I do not have a physical explanation as to why, so we might be able to see that in another video. For now, thanks for watching. Please subscribe for more videos.